So in this video today, we're going to be talking about fractions. So in the last video, we talked about integers, right? Those nice round numbers. Well, now we're moving on to fractions, which you'll see will allow us to kind of go in between integers a little bit. So I'm just going to jump right in. The first thing that we're going to kind of ask ourselves is, what is a fraction, right? And so a fraction is simply a way of writing parts of a whole. Okay? So a fraction is parts of a whole. And what that means is best described by a picture, I think. So if we have a circle, right? So let's make a nice circle here. And we divide this circle into 3 equal parts, right? Now, let's say that I color in this part of the circle and also this part of the circle. Okay, so now you might ask, well, how much of the circle is colored in at this point? 2/3 of the circle. Why? Because we split it into how many parts? We split it into 3 equal parts. And how many of those are filled in? There's 2. So this is a fraction right here. And we say this as 2/3, right? Because it's 2 of the 3/3 of that circle. And so basically the way we write a fraction is just, we have the number on top, we have a number on bottom, and then they're separated by just a horizontal line, right? And we actually have some names for these different parts of a fraction, right? So this number on top here, this guy, we call the numerator. And this guy down here, we're going to call the denominator. So in practice, what this means, and by the way, these are really important to get down because in math, a lot of the times they're going to refer to the numerator and denominator, and they're super easy to get mixed up. You're like, okay, was the numerator on top or the one on bottom? I don't know. The numerator is on top, the denominator is on bottom. I tried to come up with a way to remember that, but I couldn't figure out anything super simple to help with that. So I just remember, numerator's on top, denominator's on bottom. Okay, so the numerator and denominator, the reason we have both of these is that they give us different pieces of information about this fraction. So you'll notice the denominator here, this guy tells us how many parts the whole is divided into, right? In this case, we divided the circle into 3 parts, so that's why we have the 3 on the bottom here. The numerator tells us how many parts are filled in, right? So it was 2 in this case because we had 2 sections of the circle colored in. So so the numerator tells us how many we have. The denominator kind of tells us how many we want to have to make a whole, right? So because of this, whenever the numerator is equal to the denominator, that means we're going to, like, okay, let's say in this case, R2, what if that were a 3, right? Well, if that were a 3, that would mean we'd have all 3 sections colored in. So that completes the whole, right? If the numerator is equal to the denominator, in the case of 3/3, for example, it equals 1 whole, or just 1, in all cases, okay? And so, again, practicing using variables to write these general statements, we could rewrite this as A over B is equal to 1 when A is equal to B, and we have one other requirement, which is that B is not equal to 0. The reason for that is because it turns out fractions are really just division, and I'm going to talk about that more in a second. So dividing by 0 does not work. We can't have 0 in the denominator. It's undefined. So if b is not equal to 0 and a is equal to b, then we know that the fraction is going to equal 1. So just some more examples, 2 over 2 equals 1. 5 over 5 equals 1. 100 over 100, right? All these are going to equal 1. What if I try to do 0 over 0? That's not 1. That is undefined. The reason it is not 1 is because of this requirement right here. B cannot be equal to 0 when we're doing this. Okay, so we kind of have, that's a very important thing to remember with fractions. If the same number's on the top and bottom, it's always going to equal 1. Why? Because you're filling in all the sections you've created, right? You have the same amount of sections filled as you have sections, right? All of the sections are filled because the numerator is equal to the denominator. So that is going to be important when we're working with other algebraic expressions, because this is going to come up a lot. Number over itself is always equal to 1. And we can actually use that fact. We're going to use that when we're adding and subtracting fractions, and you'll see how this becomes very important and very useful. The next thing we're going to talk about is equivalent fractions. So let's say we have two fractions, and I'm going to give an example again, 2/3. How do we know if it's equal to another fraction, right? Well, first of all, we know it's going to be equal, or we say equivalent. It's going to be equal to another fraction if the numerators and the denominators are both the same, right? If it's 2 and 2, right? And then this is, oh, that was not a very good arrow, but okay, that's 3 and 3, right? They're the same, so they must be equal because they're going to come out to be the same amount. But there's actually another way we can have two equivalent fractions, and it's if we multiply it by a fraction that's equal to 1, right? Because if you think about it, any number, say 5, when you multiply it by 1, you just get itself, right? Multiplying by 1 doesn't do anything. So what if we took a fraction like 2/3 and we multiplied it by another fraction that happens to equal 1? We just talked about that, and it's up here. All these fractions that we just talked about, all of those are equal to 1, right? So let's say we take one of them, say 2 over 2, and we're going to multiply that times 2/3, right? Again, this is exactly the same thing as multiplying by 1, and we know multiplying by 1 doesn't change the fraction at all. So if we multiply this, and I should have, we will cover multiplication of fractions in a second, but I'm just going to do this, and I think you'll kind of see where it's going. So 2 times 2 is 4, 3 times 2 is 6. So now I have 4/6 is the same thing as 2/3 times 1, right? Which is the same as 2/3. So we can actually say that 2/3 is equal to or equivalent to 4/6, right? So that is kind of, you can't always just say, oh, those are not equal if they have different numbers. You have to check, well, are they actually the same number but multiplied by 1 so the actual numbers look different? And that's just, that leads us into the idea of simplified fractions. So actually, before I move on to that, let's just, I like to practice this, concept that we can use variables to write general statements about numbers. So let's just write this idea here that, two fractions are equivalent even if they're multiplied by 1. Let's just write this in variable form so it applies to everything, right? So what if we have, we'll say a over b, right? That's our regular fraction, right? That's going to equal a over b, sorry, that was a little long. A over b times c over c, okay? When b is not equal to 0, and c is not equal to 0. Again, these zeros are just because we can't have 0 in the denominator. I just have to put these here to make this technically correct. Okay, so let's wrap that in red to just kind of make it clear what we're talking about here. Okay, so a over b is going to equal a over b times c over c. What that means is two fractions are equivalent if they are the same fraction or the same fraction multiplied by a constant, right? So in some cases, for example, if we're just writing, 2/3 equals 2/3, that's actually the same as writing 2/3 times 1 over 1, right? Because these ones won't change anything. That's where this constant part comes in. So that's our kind of our definition of equivalent fractions. And so, because we can do this weird thing with fractions where the numbers change, but it's really the same thing, we have a concept that we need to learn about called simplified fractions. And what that basically means is that the fractions have come to a point where they're down to its smallest state. It'll kind of remind us of the prime factorization stuff we had talked about before. 2/3 is an example of a simplified fraction. Why? Because because there are no common factors between the numerator and the denominator. So to kind of illustrate that, I'm going to give us an example of a non-simplified fraction. So let's say non-simplified, and I'm just going to give us the example that we just worked with a second ago, right? That was 4/6, right? So 4/6. This is not a simplified fraction. And the reason is, let's just factor these, the numerator and the denominator, so we can kind of see what's going on in here. This is the same as 2 times 2 over 2 times 3, right? The reason that it is not a simplified fraction is because we have these common factors. We have this common factor of 2 here. And it turns out that whenever you have common factors in a fraction like this, they actually cancel each other out. And the reason is because, again, a fraction is really just division. So this is 2 divided by 2, which is equal to 1, right? We just looked at that. Any number divided by itself in a fraction is going to equal 1, right? And so this is really the same as saying 1 times 2 over 3, right? Which is just 2/3. So this right here is what we call the simplified form of this fraction over here, right? They're equivalent. We didn't do anything that changed the value of it, but we changed the numbers on it by canceling those common factors. So a simplified fraction is one that has no common factors, right? Like this 2 and this 3, they have no common factors. Let's do another example, I think, because I think that will be helpful. Let's do this large fraction here. I'm going to throw us off a little bit by adding a negative sign in the mix. It's not going to be that big of a deal, but we'll do it anyways. 315 divided by 770. So again, when we're wanting to simplify a fraction, first of all, we don't know if this is a simplified fraction or not. It could be completely simplified. It's not, which I'm just going to tell you that because I've looked at this already. But whenever we're trying to simplify a fraction, we're going to start by just factoring it out, right? So what is 315? And again, this is kind of this is going to be good practice for factoring because these are large numbers, right? It's hard to factor. If you look at this, it's going to be, first of all, we know it's going to be divisible by 5 because it is this, it ends in 5, right? And I don't think I went over those rules in the 1.1 video, but we know it's going to be divisible by 5 if the number ends in 5 or in 0. So this happens to be divisible by 5, and so let's see, if 315 divided by 5, that's going to be the same as, for each 10, it's going to be 2 5s, right? So 31 divided by 2 is 15.5. And then we have that extra 5, so that kind of resolves that. Basically, you can just use a calculator. It's going to be 315 divided by 5, 63. Okay, so this is the same as 5 times 63. And we're just going to go step by step with this. 770 divided by, it's easier to divide by 10 in this case than by 5. So this is going to be 10 times 770. 10 times 77. Okay, so what's 63 divisible by, right? It turns out this is also divisible by 3. We know that because if all the digits in the number add up to something divisible by 3, then the entire number is divisible by 3. 6 plus 3 is 9. So what happens if we divide 63 by 3? We're going to get 3 times 5 times, and actually we could have divided by 9, which is 3 times 3, but we'll just divide by 3 for now. That's 21. And then down here, I'm going to split this 10 into a 2 times 5, and we also can pull a 7 out of that, right? 7 times 11, right, is equal to 77. So we actually, at this point, the denominator is fully factored, but we're going to also factor the numerator further. 21 is 3 times 7, right? So I'm going to bring that 3 to the front. So we have 3 times 5 times 7. And then the denominator was 2.5 times 7 times 11. Okay, now, that was just getting it factored, but I actually... none of these equal signs are actually true. Why? Because I need to remember to bring this negative along, okay? This negative sign goes here, here, and here. That's literally all the negative sign does. I just added that to kind of make this a little more tricky, right? But all the negative sign is doing right here, it's just tagging along. And so now, this is our factored form of the fraction. If you remember, it's because this was a long factorization, our ultimate goal is to turn this into a simplified fraction, or see if it is already simplified. And so let's go over here and just say simplify. So now that we have our factored fraction, we can look and see if there's any common factors between the numerator and the denominator. So we have negative 3 times 5 times 7 divided by 2 times 5 times 7 times 11. Do we have any common factors here? Yeah, we do. We have these 2 7s, right? And we have these 2 5s. And so what we can do, cancel those out, right? So now our simplified fraction, because we took out all the common factors, it's going to be negative 3 times 3 divided by 2 times 11. This is our simplified form of the fraction. We can verify this. They're in their prime factorization, so we know they can't be factored any further. And we can see here, there are no common factors going on. So now we just evaluate this, right? Turn those factorizations back into the numbers. So 3 times 3 is 9, and 2 times 11 is 22. So negative 9 over 22 is the answer there. This is a simplified form of this fraction. So let me just kind of make that clear here. These two numbers, these two fractions are exactly the same. They are equivalent, right? We can write negative 9 over 22 is equal to negative 315 over 770, right? That's still true. The difference is that we took out those common factors, which remember are really just ones, right? Whenever you have a 5 on the top and bottom, that's really just a 1, right? So we can take that out and it won't do anything. It won't change anything. So this is the simplified form of that. That's really all you need to know for fractions, for simplified fractions. So now that we've kind of gotten that down, we're pretty close to being ready to doing division and multiplication with fractions. There's just a couple of things that I want to stress about fractions that they don't necessarily fit into anything else. So I'm just going to put them out right here. First of all, and I've already said this before, fractions are really just division. So if we say a over b like this, right, that is exactly the same as writing a divided by b. Why do we write it this way? Well, it just gives us, there's a lot of things that are easier to write like this. If you have really long things being divided by each other, it makes it really clear what's on top, what's on bottom, what's being divided. We can see these factor things really well. It's just a different way of writing it, but it means exactly the same thing as division. So for example, we could write 36 over 9. This is a fraction, right? It's the exact same thing as saying 36 divided by 9, which is equal to 4, right? Okay, so that's the first thing. The second thing is that it's just one of those special things, kind of like how we know if a number over itself is 1. Well, it turns out that any number over 1 in a fraction is actually just equal to that number itself. And also, we could write this backwards, saying any number is going to equal itself over 1 in a fraction, like this. Okay? What do I mean by that? Well, that means, let's say I have, let's just take 2 over 1, that's equal to 2. If we take 3 over 1, that's equal to 3. If we look at the second sort of way of writing it, we could say, okay, 54, what's that going to be the same as? 54 over 1, right? Why? We're just dividing by 1, right? Because a fraction is just division. This is really just saying 54 divided by 1. What happens when you divide by 1? Nothing. It doesn't change anything. So when we say 54 over 1, that's the same as 54. And so this will just be helpful, especially if you're doing, in science classes, unit conversions, things like that. A lot of the times it's helpful to write a number in this form where it's divided by 1. So it makes it really clear when you're trying to cancel things and do stuff like that. So I'm just putting that out there. And then lastly, if you have a negative sign, right? So negative a over b. What do you do with that negative sign? What is actually negative here? Well, you could put the negative sign out here, but it turns out that it literally doesn't matter if you put the negative sign out there or on the numerator or on the denominator. So this is the same as if you just said negative a over b, or if you said a over negative b, right? It'll all be the exact same thing. And so don't worry about the negative sign being anywhere. Now, if you have a number where you have negative a over negative b, that's a little bit different. It turns out these negatives just cancel each other. So that's just equal to a over b. But if you have, just one negative sign floating around, it doesn't matter if it's on the top or bottom. Put it wherever it's convenient. As long as you keep only one, right? If you add another one, then that is incorrect. But if you just keep the one and put it, it doesn't matter where you put it on that fraction. Okay, so now that we have all that, we can move on to the multiplication and division of fractions. So fraction, oh, that's not an F. Fractions, mult and div, right? So when we and the reason, so you might notice with integers, I went over addition and subtraction first and then multiplication and division. With fractions, I'm going to start with multiplication and division because it's it's really simple with fractions, and adding and subtracting fractions is a little more complicated, and you'll see why in a second. So multiplying and dividing fractions. Well, let's start with multiplication. When we multiply two fractions, so let's say we say a over b times c over d. It's super simple process. All we're going to do is we're going to say a times c, right? We're going to multiply the numerators, keep that division or fraction line, right? And then we're going to multiply the denominators under it. That's all. And so let's give an example here. I have 2/3. So 2/3 times 7 over 11. Well, this is going to be the same as we multiply the numerators, 2 times 7, and then we multiply the denominators, 3 times 11. And so that's going to equal 14 over 33, right? That's how you multiply fractions. Super easy to do. Yeah, I think this will not be something you'll struggle with that much. It's a little bit different when you're doing division of fractions, right? So let's do division. Oh, wait a second. Oh yes, this is important. So let's say you're multiplying a fraction by a regular number. So for example, if I had 2 times 5/6, right? This number is always going to multiply this numerator and not that denominator. The reason is, and again, this is why this is kind of helpful, 2 is actually the same as 2 over 1, like this, right? And so now it's clear, okay, this 2 is supposed to multiply times the numerator, and the 1 just goes to the 6, and so the 6 doesn't change at all, so this is going to be 10/6, right? So just remember, if you're multiplying by a regular number, then it always goes on the top, right? And I actually have an example set up over here. This is negative 12 over 5, right? And see how I'm using these negative signs again. Times negative 20x, throwing a variable in there. Again, same thing. Multiply that by the numerator, right? And so I'm actually going to just start again because I think this is helpful. Write this as itself over 1. It makes it very clear what we're doing. And then I'm going to use that thing again where I put the negative on the top, see, because it's the same wherever you put the negative. I'm putting it on the top because it's convenient, because then these guys are going to cancel, right? So then 12 times 20 is 240. We keep the x because we weren't able to just combine that, right? And then this is divided by 5 times 1 is just 5. We can actually simplify this now, because it turns out that 240 divided by 5 is actually 48 over 1, and we still have that x, right? And because of this thing that we talked about up here again, we know that 48x over 1 is just equal to 48x. So that's another longer example of how this works. When you're multiplying a regular kind of number times a fraction, you always multiply by the numerator. And I would personally recommend just write it over 1, right? If you don't feel totally confident in what you're doing. Okay, so division is going to be a little bit different, and before we can do division, we have to know this idea of a reciprocal. Okay, and practically speaking, all a reciprocal is when we flip a fraction over. So let's say we have 2/3 and we ask for the reciprocal of that. So we say reciprocal. If we take the reciprocal of 2/3, we're just flipping the fraction over. So that just means 3 over 2, right? If we had 5 over 6, that looks like a 6 over 6. If we had 5 over 6, the reciprocal would be 6 over 5. A super simple concept. And so what we can do, let me just write it in variables again. The reciprocal of a over b is going to be equal to b over a, right? When b is not equal to 0 and a is not equal to 0, again, because we can't divide by a or b. But that's what a reciprocal is. And so, now that we know this, we can say the definition of division here. It turns out division is the multiplication of the reciprocal. What does that mean? Well, it's an example is going to help with that. Let's say we have a over, yeah, okay, I'm just gonna put it like this. So if we have a over b, and we want to divide by c over d, then it's the same thing if we turn this division into a multiplication sign and then take the reciprocal of c over d. So what that means is this is the same thing as a over b times d over c. Right? So all we did is the division became a multiplication, and we took the reciprocal. We flipped that other fraction over. So now we have a times d over b times c, right? And we know how to do that because it's just multiplication. A times d, b times c. And that's literally all it is. So division is actually the same as multiplication. We just have to take that reciprocal, right? So let's do like a more concrete example. We have 7/18. And I think this is straight out of the textbook too. So divided by negative 14/27, right? So again, what do? So when we're dividing two fractions, we multiply by the reciprocal. So we're going to, the first one's just going to stay the same, right? The division sign becomes a multiplication sign, and we flip over this other fraction. So this is going to become negative 27 over 14. Now, we can do some canceling here, but I'm just going to combine them right now, and then we'll simplify it at the end. So negative 189 over 252, okay, is the answer from that. So 7 times 27 is 189. 18 times 14 is 252. That's all I did there. So now let's take this fraction and simplify it, because usually we want the simplified form of a fraction. Oftentimes it's much more useful to because it's just kind of that base form, right? So if we simplify that, we're just going to use our same process of we factor it out. So this is going to be 3 times 3 times 3 times 7 for 189. I already have this written out. I'm just, for the sake of time, just copying from here, my notes. So 2 times 2 times 3 times 3 times 7 is 252. So now we identify the common factors. So we have a common factor of 7 here and 2 common factors of 3, right? So all of those are going to be canceled out, right? So 3, 3, 3, 3, and 7 and 7. And so now we're going to be left with negative. Always keep that negative sign. Don't forget him. And this is 3 over 2 times 2, which is negative 3/4, right? So we had this huge fraction up here, and it became this tiny little guy down here, right? And so it's so much easier to deal with these small fractions. Always try and simplify your fractions as much as possible. Almost always. And in addition and subtraction, we're actually going to use the idea that we can turn it into a non-simplified fraction, and so you'll see how sometimes that is useful too. But for the most part, it's always nice to have a simplified fraction rather than a non-simplified one. Okay, you might remember me saying, because I said this a few times, a fraction is really just division. Well, it's also true that division is really just a fraction, kind of, right? In other words, if we take, sometimes when you're dividing fractions, you might actually see a fraction on top of another fraction, right? Which is really weird looking. So 2/3 over 7/11, right? I'm actually going to put these in parentheses just to make it clear what we're doing. This looks really weird, and honestly, it's kind of ugly. But it's exactly the same as division, right? Because we know a fraction, right, represented by that line there, a fraction is equal to division. It's the same as division. So what we can just do is say this is the same as 2/3 divided by 7/11, right? And now suddenly it's become much simpler. All we have to do is, again, we are multiplying by the reciprocal, so turn that into a multiplication, and turn this into the reciprocal, and just do that multiplication. If you want to just do this really quickly from this fraction form, you can kind of skip that division conversion step, and you can just take this fraction right here and you can just flip that over, right? So you pull it out and flip it over, kind of. So just equals 2/3. So we're going to multiply and we're just going to pull it out and flip it over, right? 11/7. It's the same as that other step. Again, I like shortcuts because they help me go faster, but if the shortcut makes you mess up, just do it the long way. It makes it more clear. So that is that. Okay. I forgot to tell you, when we have this kind of a situation, right, where we have a fraction on top of a fraction, we call that a complex fraction. So complex fraction. Again, we just name everything in math. We give everything a special name. So when you see the words complex fraction, it just means a fraction on top of another fraction, or like a fraction inside a fraction. Don't get too caught up with the naming. It's really just, we have big names for simple concepts sometimes in math. That's just how it is. Okay, so now we can get to the really challenging topic here, but I don't think it's going to be too bad. It's adding and subtracting fractions, right? So how do we do that? Let's say, so I'm just going to, for the sake of putting this in the notes, adding and subtracting, right? If we have two fractions, and I like to use kind of the same numbers when I'm going through stuff like this, so we're going to go back to our 2/3 and our 7/11, right? What if we wanted to add these, right? Well, based on, what we see for multiplication, the intuitive thing to do would be, and I'm going to put a question mark over this, because we don't know if this is right yet, would be to add the numerators and then add the denominators, right? That makes sense. But it turns out that you cannot do that. It's not that simple. And that's part of that. That's just part of the fact that fractions are division. It just doesn't combine that way. The way we can combine them when we're adding them is if we turn these denominators and we make them the same number, right? If we had something like 2/3 plus 3/3, right? Because these are the same thing on the bottom, we can actually just add the tops, right? That we can do. So in this case, we just add the numerators. 2 plus 3 is 5. And then the denominator just stays the same. We don't add those 3's on the bottom. They just stay as 3. And the reason why is because if we have 2/3 plus 3/3, how many thirds do we have now? 5, right? 2 plus 3. So if we could get it to something like this, then it would become really easy, right? How could we get these two numbers over here, right? This 2/3 and the 7/11. How could we get them to have the same number on the denominator without changing the actual value of the fraction? Like, I could write it just as 2/11, right? And now they have the same thing on the bottom, right? But now this 2/11 is not equal to 2/3, right? So we just changed the entire addition, right? And we don't want to do that. So how could we make these the same thing without changing either of those fractions? The key to doing that is what we just learned at the very beginning about how we can multiply by another fraction that equals 1 to change those numbers, right? So for example, 2/3, right, is if we multiply by, I'm just making this up off the top of my head, 5/5, it's the same as multiplying by 1 because we know 5/5 is just 1. And so we would get 10/15, right? 10/15 is the same as 2/3. It's equal to 2/3, but these numbers are different, right? And so what we can do is we can use that to make these two numbers in the addition equal to each other. The only thing we have to worry about is what are we going to multiply each number by, right? The way we find that is actually going to be based on another concept from a previous video, the LCM, the least common multiple. I'm not going to re-go over how the least common multiple works here. So if you don't remember that, just go back to the 1.1 video. But because it's in this special situation with adding fractions, we're going to call it another thing because they like doing that. So where the least common, or the LCM was the least common multiple, this is going to be the LCD, which is the least common denominator, right? That's a little big word. And it's exactly the same thing as the least common multiple, but they just wanted to call it the least common denominator because it's a specific situation. So what we're going to do is we're going to find the least common multiple between 11 and 3. So again, how do we do that? Well, we start by factoring the two numbers. Well, it turns out these are both primes. We don't have to do any factoring. They're just themselves. Okay, so now that we've done that, now we just have to build the least common multiple from that, right? And so what we do is we put one of them in, and then we just multiply by whatever else we need to include that one. It happens to be 3. In this case, it's a very simple least common multiple, right? Or I should say least common denominator, right? 11 times 3 is going to be 33. So this is the number that we're going to have on the bottom of our fractions. So that's really cool, right? Now we just need to say, okay, how do I get from 2/3 to 33, right? And how do I get from, oh, sorry, that's not 7/3, from 7/11 to 33, right? How do we get those 33s on bottom without changing those fractions? Well, what we do, how do we get from 3 to 33? That's, we just multiply by the rest of it, right? 11. So we're going to put 11 on the bottom here. So that 11 times 3 there is going to equal 33. And then to keep this equal to 1, we have to put an 11 on the top too. So now this right here is just equal to 1, right? Because it's a number over itself. So we're not changing what 2/3 is. We're not changing 2/3's identity, right? If you might think about it like that. But this 3 is going to become a 33 by multiplying by 11. And the way we get that is by taking the 33 divided by 3 to get whatever's left over from this factorization here, which happens to be 11 in this case. And then over here, we're going to multiply by what? Well, if we take 33 divided by 11, we're going to get whatever's left after you take out the 11 from here, which is 3. So over here, we're going to multiply by 3, and same thing, the 3 has to be on both the top and the bottom for this to be equal to 1, so that we're not changing the identities of the fractions. And so now we're in a place where this becomes 22 over 33, and this becomes 7 times 3 is 21 over 33. Now we have 22 over 33 plus 21 over 33. That's going to be 43 over 33. And that would be the answer to adding those. So it's a very simple to do the addition. It's just that we have this extra step of finding the least common denominator, and then we have to figure out, okay, what do I have to multiply by to get that least common denominator on the bottom of both fractions? It's going to be exactly the same thing with subtraction. I'm going to do another example here. Let me see if the textbook has a really good example for this. I'm going to look in their questions here. Okay, so this is a good one. 7 over 12 minus 9 over 16. So this one will be a little bit more involved with finding the least common multiple, right? So again, we can't just subtract them because we need these to be the same. So to get them to be the same, we're going to get that LCD, right? So let's just kind of go over here on the side. Okay. We're going to start by factoring the two numbers on the bottom. So this is 12, this is 16. What is 12? Well, 12 is 3 times 4, which is equal to 3 times 2 times 2, or 2 times 2 times 3, or whatever order you want it in. 16, that's 4 times 4, which is equal to 2 times 2 times 2 times 2, right? And so now, let's build that LCD. So we're going to say, okay, well, we need at least 4 2's, right, from that 16. 2 times 2 times 2 times 2. And then we're also going to need that 3, right? And so I just, for the sake of this, you can see that's in there, right? And so is that. It is also in there. So that is our LCD, and that is going to be 2 times 2 times 2 times 2 is 16, and then we're multiplying 16 by 3, and that's going to be 48. Okay, so that's our LCD. That's what's going to go on the bottom. So let's just kind of rewrite this with that on the bottom. And now, what are the things we're going to need to multiply by, right? So actually, let me move this over a little bit. We're going to take that, 48. We're going to divide by our first number, 12, and that's going to tell us what we need to multiply by to get to 40. Yeah, multiply by to get from 12 to 48. That's going to be equal to 4, because 48 over 12 is 4. Okay, so 4 is going to be multiplied here. So we're going to multiply by 4 over 4, right? We need to have it on both the top and bottom. So it is equal to 1, so we're not changing the identity. I'm just stressing that because it's important. Okay, the other one was 16, so we're going to put that here, 48 over 16. That's going to be 3, right? And so we're going to multiply by 3 over 3 over here. And so that will equal, so I'll kind of go down to here. 4 times 7 is 28 over 4 times 12 is 48, right? Then 9 times 3 is 27 divided by 16 times 3, which is 48. And so we're going to get 28 minus 27 is just 1 over 48. So you see the subtraction is the same as the addition. We're just subtract those numerators and keep the denominator the same. So hopefully those examples kind of helped get this concept down. And when you're adding, subtracting fractions, you need the denominators to be the same. You do that using the LCD, which is just the LCM of the two denominators. And that is really the extent that you need to know for fractions, right? Now you could get a little bit more involved with some of these expressions with fractions. Can be a little bit more complicated. Specifically, I haven't done much with variables yet, right? So I'm just going to choose a problem with variables, which is an example from the textbook. Let's do... Okay, let's do... This one's good. This is just on simplifying fractions. Okay, so we're going to simplify. Actually, no, you know what? Let's do something that combines all the things, or a lot of the things we've learned. So let's go kind of at the very bottom of everything, right? Or you know what? I guess I could just do this. I could just make up an example myself. So what are we going to want to do? We're going to want to do multiplication. Let's do a division. Let's do an addition. So this is going to be complicated. Yikes. Okay, let's do 3/4 times negative, or actually, this one will be positive, times 5/6 plus, okay, I'm getting ahead of myself here, plus 4/5, and that's going to be divided by, or yeah, we'll just do it like this, and divided by negative 7/8. Okay, so this was totally random off the top of my head. You watched me come up with this. Let's just solve this using everything we've learned. So first of all, always use PEMDAS when you're evaluating these expressions, right? Our order of operations. Multiplication and division happen first at the same time, right? So 3 times 5 is going to be 15, right? We're just multiplying those numerators and then multiplying those denominators. 6 times 4 is 24. Okay, then we're going to have plus, right? And then what's going to go in here? It's going to be negative because we have, different signs and we're doing division. Okay, 4 divided by 7/8. So actually, we're going to rewrite this as being 4/5. So how do we do division of fractions, right? We multiply by the reciprocal. So that's the same as 4/5 times negative 8/7, right? The reciprocal doesn't change the negative at all. Okay, now we can say this is equal to 15/24 plus, and then we're going to put in here, it's going to be negative. We're multiplying with different signs. 4 times 8 is 32, and 5 times 7 is 35. So that's what we're going to have. Okay, now we're adding a negative, so that's the same as subtracting. So that's going to be 15/24 minus 32/35, right? Okay, now we want to do the subtraction, but these denominators have to be the same, right? So we do that by finding that LCD, right? So we're going to factor the two numbers. So first of all, 24, well, that's going to be equal to 6 times 4, right? Or I'll write it as 4 times 6 so that it kind of works in order here. 2 times 2 is 4, and then 2 times 3 is 6. So 24 is 2, 2, 2, 3. And then we have a 35, which is 5 times 7. Those are both primes. Okay, so now we just combine these into the LCD. So we're going to have 3 2s, 1 3, 1 5, and 1 7, which turns out to just be the same as 24 times 35, which is 840. And so now that'll be the number that we have on the bottom. Okay, so we got that. And then we're going to figure out what's on the top. So let's get rid of those. And then I'm going to move this so we can do our little multiplication on the sides, right? So move this here. What do we multiply 15/24 by? Well, okay, we take 840 divided by that denominator, 24. And that's going to equal, that's going to equal 35, it turns out, right? And then, so over here, up here, we're going to have 35/35 times that. Then we're going to do the same thing over here. So with 35, 840 divided by 35, that's going to be 24. And so up here, we're going to multiply by 24/24. And that's going to give us, okay, so we know the 35 and 24 on the bottom of both of these is just going to give us 840. 35 times 15 is 525. 32 times 24 is 768. Ooh, so this is actually interesting because we're taking a smaller number, subtracting a larger number, that's going to become negative, right? So this is going to be negative. And then the nice easy way to get the difference between two big numbers like that is if we just subtract 768 minus 525. That'll give us the difference, and then we just know, okay, it was the other way around, so it's going to be negative. That's just one way to think about it. So it's going to be negative 243 divided by 840. Okay, now we're going to go even farther here. We're going to make sure that we have the simplified form of this fraction, right? And so I'm going to take 243 is divisible by 3. We know that because 3 plus 4 is 7, and 7 plus 2 is 9. 9 is divisible by 3. So that'll, if we take 3 out of it, we're going to get negative 3 times 81 divided by, okay, 840 is divisible by 10, which is the same as 2 times 5 times 84. Okay, let's keep on going. 3 times 81, well, 81 is 9 times 9, right? 2 times 5, okay, 84 is divisible by 2. So if we take a 2 out, another 2 out, that's going to be 2 times 42, which is also divisible by 2, so we'll get to that. Okay, these 9s are both 3 times 3s, right? So 3 times 3, and then another 3 times 3 here. This one just came from right there. And then this is all over, that was a terrible line. All that is over. Let me bring that other 2 out, and we're gonna, well, no, okay. 42 is also divisible by 2, right? So that's gonna be 2 times 21. So 252 here, and then this just became 2 times 21. 21's not divisible by 2 anymore, but it is divisible by 7 and 3. So this is going to be 3 times 3 times 3 times 3 times 3. So you might actually notice this 243 on the top was actually the same as 3 to the 5th. I did not plan that. That just happens to be the case, and you can tell that from the prime factorization. Okay, and so then this is going to be 2, we have 3 2's, right? 2 times 2 times 2 times 5 times 21 is just 3 times 7, right? Okay, so we all this, and the only thing we really get to cancel here is one pair of 3's, right? So those cancel, and now we put everything back together, and we get our simplified fraction, right? So we're going to get 3 to the 4th on top, which is that 81, right? Because 3 times 3 is 9, times another 9 is 81. And then down here, I'm just going to multiply all these. So 2 times 2 times 2 times 5 times 7. That's 280. So 81 over 280, that's the simplified form of that fraction. So that is our final answer to this problem up here. So now that you have seen how we, actually let's do this in red because it's really just quite an accomplishment. Now that you've seen how this works in putting all this together, I hope that was helpful, and you'll feel confident working with fractions now. The next video is going to be about decimals, and then we just have one more video after that in chapter 1, and so then we'll get into the real algebra 2 stuff in chapters 2 and onwards, and so that's where it's really going to get exciting. But this was great. We talked about multiplying, dividing fractions. We talked about adding and subtracting fractions, complex fractions, where we have a fraction on top of another fraction. These are difficult concepts in math, so I do recommend doing more of the exercises from the OpenStax textbook. The link will be in the description of the video for that textbook. And other than that, I'll see you in the next video.